Okay, guys, welcome back to the second half of chapter 6. We're going to be discussing object-oriented design, so OOD. This discussion will be very entry-level discussion on object-oriented design. There's actually classes that go over how to design object-oriented programs. So this is just an overview because starting with the next chapter, your programs are going to be where you're going to be creating your own class with with the data and the methods that go with that class. So let's take a look at, let me go ahead and share my screen. And there we go. And look at the simplified methodology of how we design an object-oriented program. So again, this is simplified, okay? We write down the detailed descriptions of the problem. So somebody's going to give us the problem, and we're going to write a class to solve this problem. It could be that it takes one class, it could be that it takes multiple classes. We're going to identify all the relevant nouns and the verbs. So we're going to do this together in just a second. So nouns are words that are a person, place, thing, animal. So for example, Jeanette is a noun, girl is a noun, t-shirt is a noun, that kind of thing. Verbs are action words. So action words are like jump, get, set, move, that kind of thing. From the list of the nouns, we're going to select the objects. We're going to identify the data components of each object. So it could be that we just have one object or we have multiple objects. We're going to see what kind of data those objects need. And then we're going to list the verbs, and these are going to be our operations. So, for example, when we use the string class, when we create a string is an object. So string is the class, the object that you can create many objects, many strings, right? So let's say that we create 4 strings. One string holds a name, one string holds an address, one string can hold a phone number, one string can hold somebody's birth date. So these 4 strings are 4 objects of the class string. The class string has data. So the data is going to be the string itself, like being able to hold all those characters. So that's going to be the data. It's also going to be the length, because string class has to make available memory space for a certain size of string. So if you decide that it's a name that has 20 characters, then it's going to make 20 bytes, a size of 20 bytes in memory. So that's the data. And then the verbs, the actions, the operations on the string are those methods that you've been using, like the compare method, or getting the length of the string, or being able to change one of the characters in the string. I'm trying to think. Oh, you also used the method that takes a string and can change it to upper or to lowercase. So those are the methods, those are the actions or the verbs. And this is how we're going to be programming from now on. We're going to be using creating a class, creating data that goes with the class, creating methods that go with the class. So when you use the string method, compare or to lower or to upper, you don't know what's happening in the background. It's just magic that the letters turn to uppercase or to lowercase. But now you're the programmer, you're going to be creating those methods that change things to upper or to lower, count how many characters are in something. So here's an example of a problem statement. The problem statement says, write a program to input the length and the width of a rectangle and calculate and print the perimeter and the area of the rectangle. So first of all, let's take a look at the nouns. The nouns are, well, program is definitely a noun. But here we're just saying write a program. Write would be a verb, but let's not worry about the write a program. That's just like extra words. To input the length, so input would be a verb, length and width would be nouns. So we're going to input the length and the width of a rectangle. Rectangle is a noun. Calculate is the verb. Print is a verb. We're going to calculate and print the perimeter and the area. Perimeter and area are nouns. And again, rectangle is a noun. So the nouns are length, width, the word rectangle, perimeter, and area. So by looking at this, we see that we're talking about a rectangle. We're going to do something with the rectangle's data, the length and the width. We're going to do some calculations on the to find out the rectangle's perimeter and area. We're going to print on the perimeter and area of the rectangle. So it would make sense that this class would be called rectangle because you're doing things for a rectangle. So you would create a class named rectangle, and the data for this rectangle would be the length and the width. Those are the two things that you have to be able to figure out and calculate the area and perimeter. And then you have to think, well, what does the user want to do? Well, the user, number one, needs to give you the input, the length and the width, and then the user wants to see the perimeter and the area. So you're going to calculate the perimeter and the area for them. They don't have to do it. So you're going to create this really cool class that does everything for the user. And it would look something like this. So this is the name of the class. This is the data, the length and the width. So when the user creates a rectangle, when they create an object called rectangle, they would give you the length and the width. Just like when we use the J-frame class, we gave it the size of the window that we wanted. So we gave it also the length and the width. So then we have to code these in gold here. We have to code these what are called methods. These methods, where it says set length, so the user could then, they create a rectangle that's a 10 by 5, let's say, and if they wanted, they could change the length later. They could set the width to something different. They can get the length. Maybe you have a rectangle, you want to know, well, what length is this rectangle? So you get the length, get the width, compute the perimeter, compute the area, and print. These are going to be all created by you, the programmer. And whoever uses this object, it's going to make their life simpler because they don't have to know how to compute the area of a rectangle. They don't have to know the formula. All they have to know is call compute area, and boom, it computes it for them. Again, like magic. So here's another example of a problem. This problem says, an inoperable candy machine has a cash register and 4 dispensers to hold and release items sold by the machine. So think of a candy machine, and you know, in the candy machine, like you can get candy, gum, chips, and each one of those, the one that holds all the pretzels, that is one dispenser. The one that holds all the gum, that's another dispenser. The one that holds all the chocolate candy bars is another dispenser. So this one has 4 dispensers. That's it, just 4 dispensers. And all it sells is candies, chips, gum, and cookies. So this is what each dispenser contains: candies, chips, gum, and cookies. So that's what the machine sells. You're going to write a program for this candy machine so that it can be put into operation. So we have a candy machine. It has a cash register, meaning like if the candy's worth $1.50 and I put in $2, it calculates and knows to give me back 50 cents because the candy was worth $1.50. That's what it means by the cash register. It can calculate, can tell me how much it's worth. If I put in $2, it knows how much change to give me back. Or it tells me that I need to give it more money because maybe I didn't give it enough money. The program should do the following. The program should show the customer the different products sold by the candy machine. So show is a verb. So this is going to be a method. Show what products that candy machine sells. I sell candy, I sell cookies, I sell chips, etc. Let the customer make the decision. So make would be another method. So I get to decide what I want to choose. Show the customer the cost of the item. So if I choose chips, it's going to give me how much those, it's going to tell me how much the chips are worth. It's then going to accept money from the customer. It's going to return change, and it's going to release the item. So it's going to make the sale. So once I choose chips and I put in my $2, it returns 50 cents and it gives me the item, so the sale is made. So when you have something like this, you have 3 classes. The top class is candy machine. The candy machine has 2 separate classes. One class that dispenses, one class has the cash register. So it does all the calculating and how much is it worth? Did you pay enough? That kind of stuff. This 4 here means that there are 4 dispensers. So we create one class for dispenser, and there's going to be 4 objects. And here we just have one cash register. So dispenser, the dispenser class would have the cost of the item and the number of items. So remember, there's going to be 4 dispenser classes, 4 dispenser objects, sorry. So one dispenser can be the chips. The cost of the chips, $1.50. How many chips are in there to dispense? Well, I don't know. Let's say there's 10. So this class would allow me to create and to generate 4 different objects for each thing that I sell. The class can get the count, can get the product cost, make the sales, set the product cost, and set the number of items. So these would be the methods that the programmer would develop and create. The cash register class will only get instantiated one time because all it's going to do is going to have a certain cash on hand. So I've got to have change to be able to give the person change if they give me more than it's worth. So the cash register class would accept an amount. It would return change. It would get cash on hand and set the cash on hand. So again, cash register would only create one object of this. And then we have candy machine. So candy machine would have these. So these in purple is the data. So the data for candy machine would be the types of things that the candy machine has available to choose from: candy, chips, gum, and cookies. And remember, candy, chips, gum, and cookies can be anything. It can be changed. Right now, this would be the data that it would have. And then it would have cash register. So candy, chips, and cookies would actually be 4 objects of the class dispenser. So candy would be dispenser, chips would be defined as dispenser, gum would be defined as dispenser. So you could say something like dispenser cookies equals new dispenser. And depending of how you create this, you could pass it the cost and the number of items. That's for later for us to so I can show you how to do that. And then C register would be the date, would be, you could say cash register, C register equals new cash register. So there's only going to be one of these. And then this, so this class candy machine is going to create one cash register and 4 dispensers. And it's going to have these methods here available to use. So you could call show selection, and you could call make selection. So again, each one of these is a class. The purple is the data. The gold is the methods. And how these methods are created, we're going to talk about that in chapter 8. Chapter 8 will be creating classes. We'll create all these, and it's not super hard, but it's a little different. Okay, so again, the algorithms are used to implement the operations, the methods. So if you have a show selection, then you create your algorithm. What does it mean by show selection? So step 1 is this, step 2 is this. So that's where we create that little algorithm, and then we code it for each method. Construct and implement your own methods. That's going to be in chapter 8, like I said. And then at the very end of this chapter, they talk about something called wrapper classes. And the reason they bring these up in this chapter is that in some classes, you're not able to use primitive data types like lowercase int or lowercase double or lowercase char. So a wrapper class, what that does is it takes a primitive data type and it converts it to an object so that you can use it in other classes that can only take objects. And here's how they work. So this is a variable, or yeah, not a variable, but an object. This is an object called num. The reason this is an object is because integer is the class. So this is the object num. This is the class integer. To create a new integer, I would say num equals new integer, and I would pass it the number that I want to store in this, or reference from this object. So if you remember, what happens is that num is the name of the object, and num holds an address. So num holds the address of where that 86 gets stored in memory, because num is just an object. An object only hold addresses. They reference the location of where this is stored. So when you do this right here, somebody had to implement this. Somebody had to write the code to make this work. And so the code for this, or at least the method, looks like this right here. It's this method, this constructor. This is called a constructor. So it's called public integer int num. So this constructor allows you to pass it one integer, and what it does is it initializes the value of that num that's being passed. You could also construct your object by passing it a string. So you can pass it a string, and the string can be an integer. These are the methods that you can use with integers. So once you actually create your object, so here's the object num. So now you can say num dot compare to, num dot int value, num dot, all these methods can be used. So if I want to compare to another object, integer object, I would use this method. If I want to get the integer value of that object, I would use this one. So basically it's making it, it's reverting it back to a primitive int and not an object. If I want to return the value of the object as a double, so I want to take my integer 86 and return it as a double, I can do that. Equals, if I want to see if it's exactly equal to an object, I would use this. This would be compare. This would tell me if it's less than, equal to, or not equal to. Sorry, less than, greater than, or equal to. Parse int, it takes a string. So we pass it a string and it parses into an integer. We use the parse int method when we looked at text boxes, because when you enter data into a text box, the data is, even if you like enter, like, how old are you? You enter, I'm 50 years old. It takes that 50, stores it as a string. So if you want to get that 50 and do some calculation with it, you have to parse it. You have to turn it into an integer, convert it from a string. Because strings, you cannot calculate strings. You can't say like string age plus string age. It doesn't add them. If you say string age plus string age, it concatenates them. It puts them side by side. So if you have string age is 50 and another age string is 10, it would be 5010. It's the two strings together. So these are the methods that you can use with the class integer. We also have available the class double, the wrapper class double, character, long, and float. And the methods that go with those are, I don't know if they're in your book, but you could find them online. The different methods that go with all these wrapper classes, if you need to use them. So there is a limitation, and the limitation with using the wrapper classes is that you cannot change the value stored in the objects. So once you wrap it and you make that 86 into an object, so here, once you make it into an object, you can't change the value. It just, all you can do is just create a whole new object that references a new location where you put a new value. So here's another example of how we can do the same thing. So we can say int x, integer num equals 25. So this right here where it says num equals 25 is the same thing as saying num equals new integer 25. We looked at this when we looked at strings. We could say string str1 equals Jeanette, or we can say string str1 equals new string Jeanette. So it's the same thing. So this expression num equals 25 is referred to as autoboxing of the int type. Autoboxing just means that you don't have to do new, it just here automatically constructs. It's like saying new, but we don't have to actually type in equals new integer 25. So autoboxing. Here, we can say int x, integer num, x equals num. So x equals num is equivalent or the same as saying x equals num dot int value. So this method here gets you the integer referenced by the object num. This does the same thing. This is called auto unboxing. So meaning back here, you're wrapping And so auto boxing, here you're unwrapping. So this is auto unboxing. You convert it from object back to integer. It's primitive data type. So, like I said earlier, there are some methods that you can use. I already talked about compare to. You can compare two integer objects equals just to see if those two objects are exactly equal to each other. And then this is the class int class. So the data member is int x. And then these are some of the things that we can do, the different methods is how we can construct int class. These are some other methods that we can use with the class. All right, so just a chapter summary, every graphical user interface contains a window. Various components are added to your content pane of window. So you got to have a pane, and then you add the components like text boxes, labels, and buttons. The class JFrame is used to create a window. JLabel is a class, and it's used to label your graphical user interface components and display information to the user. JTextField is used for input and output. Remember, with JTextField, if you're inputting, the person can type into the text box. If you use it to show output, you have to make it where the user cannot write to it. So you have to physically do that. JButton is another class that generates action events. So JButton, you can create a button and then you set an action listener so that you can know when the user presses the button, and when they press the button, then you, as the programmer, code what should happen when they press the button. That's an event. Action listener must have the method called action performed. Class is a collection of data members and methods associated with those members. So a class, you have data members like length and the width, class rectangle, length and width of the rectangle, and then methods that are associated with the data. So method like get length, get width, associated with that data, length and width. Methods like area or perimeter. Well, the area needs the length and the width to calculate the areas, and the perimeter also. OOD is object-oriented design, and object-oriented design always starts with a problem statement. It identifies classes required with nouns in the problem statement, and it identifies the methods required with the verbs in the problem specification. So if, for example, we go to an ATM to get money, if I were to program this ATM using a class, then I would know that some of the methods that would be like deposit. Okay, so it would allow me to deposit. So that would be add money to my account, retrieve money from my account. On the ATM, I could also check my balance. So check balance, add money, retrieve money. So add money would be a deposit, retrieve money would be a deposit, and that word is just not coming to my head right now. You deposit money, you withdraw money. There we go. So deposit, withdraw, check balance. I think that's all that you can do with an ATM. I don't know what else you could do with an ATM. And so the data would be my account balance. How much money do I have? That would be the data. And then I can manipulate that data. I can take money out, I can add money in, I can print what the balance is. So that's just a very simple example of what like an ATM would do, and how I would design it. Okay, that's the end of this chapter. Make sure that you, for this section, for the object-oriented design, you're just gonna be looking at some questions that are in your quiz. You're not gonna be doing any special programming assignment, not until chapter 8. So this might be something that that you go back and review, but we'll definitely cover it again as we start to design object-oriented programs where you create your own class and construct objects of that class. All right, thank you. I'll see you in the next video.